I will speak you about, I will come back actually because this theme has partially been, this intervention intersects with the one from Susanna Patata. I will make use of that to go a bit fast on some parts. This study is co-developed among researchers of the University of Padova, me, Andrea Santaterra, Salvatore Eugenio Pappalardo, Massimo De Marchi, and Alessandro Ceppi from the Politecnico of Milan. We already know that from the risk analysis climate change in Italy report, which was made from the CMCC, that one of the main ways in which climate change will impact within Italy it's through the increase on temperature. The presentations before already addressed the issue of heat waves, which is becoming even more pressuring issue for Italy and Europe in general. There are different ways and there is still not a clear way to define actually the concept of heat wave, because it's a phenomenon that varies a lot geographically especially. So there are different definitions in terms of time and of maximum temperatures degrees. So it's a located phenomenon. Just to cite, as also Susanna was citing before, in 2022 we had a very strong heat wave which came across Italy, across Europe and especially across Italy, with an estimation of 18,000 deaths in the whole country. This phenomenon of urban heat waves merges itself with the urban Italian phenomenon, which actually produces then the main issues related to climate justice within the city, because the lack of spatial homogeneity within the city permits and contributes to creating de facto sacrifice areas within different parts of the city. Urban Italians are generally monitored through three different approaches, from remote sensing, as we see before, through ground meteorological stations, and as in this case, from high-resolution reanalysis climate models. The general aim of this work was assess critical hotspots of climate extremes in the city of Padova. To do that, we developed three main activities. The first was by validating the URBClim model. We studied a span of 10 years between 2008 and 2017, analyzing urban Italians and with a specific focus on tropical nights and hot days. Secondly, we identified for hot days and tropical nights the most impacted areas, and derived and estimated the climate risk by merging with socio-environmental variables. And then by using citizen science weather stations, we analyzed the event of summer 2022. I will go fast on the part of the city of Padova. Apart from what Susanna already mentioned, I will just point out that half of the soil is sealed within the city, and that there is a strong lack of reference stations within the city. One is in the city center, but is located in the botanical garden, so it's not very representative. And another one is located in Legnaro, which is in the outer ring of the city. So it's very difficult to use that data as a representative of the whole city. Okay, then we used three basic datasets as sources. The one reference stations that I was mentioning before, from the Environmental Protection Agency of the region, and we also relied on the Citizen Science Network, Meteo Network, which is a wide network of citizen scientists which provides data on climatological data. And then we used the Copernicus Climate Change Service URBClim model in order to assess data within a 10-year time span. We used as a definition of hot days the days in which it was reached a temperature of 32 Celsius degrees, which represents the 19th percentile of the overall temperature within the time frame considered. Then, for tropical nights, we used a definition from literature, so 20 Celsius degrees. Then we defined group-specific risks for elderly, children, and foreigners by integrating the three components of vulnerability, exposure, and hazard, meaning the population density, the amount of the specific vulnerable group, and how much the area was impacted from urban islands using the previous mentioned indicators. Then by combining the three indexes, we compounded a global risk index. For territorial data, we used socioeconomic and demographic data as they were needed to calculate risk in an integrated way. So, a bit of results. The first part was the validation of the URBClim model assessment by using the reference station from the ARP. We have a slight overestimation of the data within the model, but it is within an acceptable range. The most critical part is on daily minimum temperature, so, for which the range is within 1.45 Celsius degrees. But in that, we should also consider that the pixel of the dataset is at 100 meters. So it's acceptable, this kind of difference within that, considering that kind of area. Then, we selected 15 pins within the URBClim model in order to assess how different land use coverages were affecting more or less the temperatures. Here you can find the graphs that show for different soil coverage classes the change in temperatures, and we have an outer ring which is of impermeable surfaces. Then we have permeable surfaces and water. So it basically confirms that different soil usage affects temperature. That is something we already partially knew, but it was confirmed within the model. Then we have two maps, one on tropical nights, one which shows the distribution of tropical nights within the city of Padova, and one for the hot days. As you can see, we have an high prevalence of tropical night. We have most of the area which is above the 45-54 threshold, which means that more more than half of the summer was at the tropical nights. We have some peaks in which we had more than 72 tropical nights per summer, on average. The situation for the hot days is a bit more mild, but it's more distributed. Also in this case, there are very, very few cases which go under the 40 days of hot days per year. Just a few results on the risk analysis. As you can see, we have, well, the model allows us to compare, basically, as they are normalized, the different urban units within Padua, the most affected areas in both hot days and tropical nights, and actually some of the specific scenarios, such as the children one, it's the Arcella. This is due both to prevalence of urban Italians, but also to a high prevalence and a concentration of both the sheer amount of population within the urban unit and the amount of vulnerable people in the area. Then finally, we tried to assess within different soil uses and the different areas from the Meteo Network Association. As you can see, we have 4 stations, and the one in Portello is within the city center, and as you can see, it performs, it shows a lot higher temperature. And then we have areas such as Legnaro, which is peripheral but still impermeable soil, which performs very, very better. And Basso Isonzo it's in a green area, but within the it's more near to the main city ring, suggesting that it's not only a close relationship with seeded surfaces that affects the temperature, but also the wider context, basically. So that's it, and thank you for your time.